Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for returning all the elements of the matrix in the spiral order. Let's look at the problem description. We are given an m by n matrix and we have to return all the elements of the matrix in the spiral order. Let's take a look at the example one. So this is a 3 by 3 matrix. If we do a spiral order traversal, we start from the top left cell and we go from left to right until we reach the last column, and once we reach the last column then we go top to bottom until we reach the last row. Once we reach the last row, we again go back right to left until we reach the first column. Once we reach the first column, we go up and we have to skip the already visited rows. So here we stop at the row 1 and then from there we turn right. So the expected output will be 1, 2, 3, 6, 9, 8, 7, 4, 5 for this matrix. Same way for this 3 by 4 matrix. 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 6, 7. The constraints are the m is equal to the number of rows and n is the number of columns. The rows and column sizes will be in the range 1 to 10. And each element's value will be in the range from minus 100 to 100. Let's look at the approach to solve this problem. So for this matrix, the expected output is 1, 2, 3, 6, 9, 8, 7, 4, 5. So we are traversing left to right, top to bottom, right to left, bottom to top, left to right. Okay. So basically we have to reduce the boundary of the matrix as we process the rows elements fully or the column elements fully. There are 4 possible directions that this traversal will be done. One is the left to right, top to bottom, right to left, bottom to top. Okay. First thing we have to do is compute the total number of elements in the given matrix and then initialize the boundary of the unvisited part of the matrix. Initially the entire matrix boundary we have to set. So the top left cell and the bottom right cells row and column index gives the boundary. So 0, 0, 0th row, 0th column, second column, second row. This is the boundary of the matrix. Okay. Then as we traverse, we have to reduce the boundary. Okay. For example, when we traverse from left to right, after processing the 0th row, then when we go down, at that time we have to increment the starting row index so that when we process this part, we will not again visit this row. Likewise, when we complete the traversal of this column, we have to decrement the end column so that this will not be visited, only the remaining 4 will be traversed. So once this right to left traversal is completed, we have to decrement the end row so that this row will not be visited again, only these 2 elements will be visited. Okay. So as we complete a row or column, and depending on the directions, either we increment the start row index or decrement the end row index. Similarly, either we increment the start column index or decrement the end column index. That's what I have listed here. So first we initialize the boundary of unvisited part of the matrix. So start row is 0 and start column is 0, which is the top left cell, and the end row end column is number of rows minus 1, number of columns minus 1. So 2, 2, which is the bottom right cell. Okay. Then we have to keep update the boundary of the unvisited part of the matrix as we complete each row. For example, increment the start row once the left to right horizontal traversal is done. So when this is done, we increment the row index so that only this portion will be traversed next. So and then decrement the end column once the top to bottom vertical traversal is done. So once this is done, decrement the end column, and decrement the end row once the right to left horizontal traversal is done. So this one, and increment the start column index once the bottom to top vertical traversal is done. So when this is completed, we have to increment the start column index. Let's look at the flowchart. Input for this procedure is a matrix. First, we initialize the out list array, and then initialize the max row and max columns and the count variable. The count variable contains the total number of elements in the matrix. Next, we initialize the boundary of unvisited part of the matrix. Start row is initialized with the row index of top left cell. The start column is initialized with the column index of the top left cell. And the end row is initialized with the row index of bottom right cell. End column is initialized with column index of the bottom right cell. Okay. Then we initialize the index of first cell to be visited in the matrix, which is the top left cell. So row is set to 0 and column is set to 0. And we need 3 Boolean variables to distinguish the direction of the traversal, whether it is done horizontally or vertically, and if it is horizontal, whether it is done left to right or right to left. If it is vertical, then whether it is top to bottom or bottom to top. Okay. So the initially we start from the top left cell and do the traversal horizontally from left to right direction. So the horizontal is set to true, left to right is set to true, and the top to bottom is set to false. Okay. Then we are entering the for loop, which process only the count number of elements. So we check whether the count is greater than 0. If so, we enter the body of the loop. First thing we do is we add the cell present at the row and column index and add that to the out list. Then we check whether the traversal needs to be done horizontally. If it is horizontal, then we have to check whether it is a left to right or right to left direction. If it is a left to right, then we check whether the current column index is less than the last column index. If so, we still have elements to be processed in the row, so we go ahead and increment the column index and proceed to the next iteration. So that will read the next elements in the row. Once we reach the end column, then we have to change the direction of the traversal. So we set the horizontal to false. And we are now next we will have to traverse from top to bottom. So we set the top to bottom flag to true. Then we have to exclude the row which just traversed completely. So the 0th row is traversed completely, then we have to increment the start row index. And then we have to update the current row index so that the next element present in the next row will be processed. So now we are doing the traversal in the vertical direction. If the direction is right to left, okay, so in that case we have to check whether the current column index is greater than the starting column index. If that is the case, then there is still element that needs to be traversed in the right to left direction. So we simply decrement the column index and proceed to the next iteration of the loop. Otherwise, we will have to do the traversal vertically next. So we set false to the horizontal boolean, and then we will go from bottom to top. Okay, so that's why the top to bottom boolean is set to false. And since we process the last row, we decrement the end row index. so that we reduce the boundary, and then we decrement the row count so that next element present in the next row will be red. So this is for the horizontal traversal. Okay, so if the horizontal is not equal to true, then we handle the case for the vertical traversal. So in the vertical traversal, here we check whether we are doing the traversal top to bottom. In that case, we check whether the current row is less than the end row. Okay, so that means there are still some elements in that particular column. So we simply increment the row index and proceed to read the next element. Otherwise, we reach the end of the column, so we have to change the direction to horizontal. So that's why the horizontal flag is set to true, and the direction is from right to left. So that's why this is set to false. Next, we decrement the end column index. Okay, so that the last column will be ignored in the further traversal, and also we decrement the current column index so that the next element will be positioned in the next row. So if we are traversing bottom to top, so in that case we check whether the current row index is greater than the starting row. If so, there are some elements present in the column, so we simply decrement the row index. Otherwise, we change the direction to horizontal. Otherwise, we change the direction to horizontal, and the left to right will be set to true, because the next traversal will be in the direction of left to true horizontally. Then we increment the starting column index so that the current first column will be ignored in the further traversal, and we increment the column index so that it points to the next element in that row. This traversal is done as long as the count is greater than 0. Once the count is 0, then we come out of this loop and we return the out list. Let's move on to coding. First, I initialize the out list, which is a slice of int. Next, I initialize the max rows, which is the number of rows in this matrix, and the max columns. Then I initialize the count variable, which is the total number of elements in the matrix. Then I initialize the boundary indexes of the unvisited part of the matrix. Start row is initialized with 0 and start column is 0. This is the top left corner cell, and then the end row is initialized with max rows minus 1, and the end column initialized with max column minus 1. This is an index of the bottom right corner cell. Then I initialize the row and column variable, which is initialized to the top left corner cell. Then I initialize the three boolean variable, horizontal, left to right, and top to bottom. This is for determining the direction of the traversal. First, horizontal is set to true, so we traverse horizontally and then from left to right direction. So starting from 1 to 3. So That's why horizontal is set to true and the left to right is set to true. Then I write the for loop which runs count number of times, and in each iteration it computes the index of the next elements to be read. So basically there are 4 cases. One is the horizontal traversal and the vertical traversal, and within the horizontal traversal either it is in the left to right direction or right to left direction. So I am just write the skeleton code. So in the case of vertical traversal there are 2 cases, one is the top to bottom and the other one is bottom to top. Each iteration the cell pointed by the row and column indexes is read and that value is added to the out list. Then I decrement the count. Next, so whenever we do the horizontal traversal from left to right direction, I check whether the current column index is less than the end column index. In that case, I increment the column index. Otherwise, we completed the traversal. So next we have to change the direction of the traversal from horizontal to vertical. So horizontal is set to false, and then once the row is fully processed, then we have to adjust the start row so that that row will be excluded from the traversal in the future. Then I update the row index so that it is pointing to the next element to be read in the next iteration. Then in the top to bottom direction also we have to set to true. Yeah, from 3 to 369. Next case is the traversal from the right to left. In this case, I check whether the column index is greater than start column. In that case, I decrement the column index. Otherwise, we process that row, so we have to change the direction of the traversal from horizontal to vertical. So horizontal is set to false, and then the top to bottom is set to false because now the traversal will be bottom to top from 7 to 4. So that's why the top to bottom is set to false, and then we have to exclude the bottom row. So the end row will be decremented. And the row index also decremented so that it points to the next element to be read in the next iteration. In this case, that is 4. Next, in the case of vertical traversal, when we traverse from top to bottom, I check the row is less than the end row. In that case, I increment the row index. Otherwise, we completely process the column. So now we have to change the direction of the traversal from vertical to horizontal. So now horizontal is set to true. So once the vertical, now we have to set the left to right to false because now we have to traverse from left to right direction. Then we have to exclude the current column which was processed, so the end column will be decremented and the column index also decremented so that it points to the next cell to be read in the next iteration. So the last case is the bottom to top traversal. So in this case I check whether the row is greater than start row. In that case I decrement the row index, otherwise we completely process that column, so we have to change the direction of the traversal from vertical to horizontal. So the horizontal is set to true and the left to right is set to true, because in this case we have to traverse from left to right. Okay. Then we have to exclude the column which was processed just now, so the start column will be incremented and then the column index also incremented so that it points to the next element to be read in the next iteration. Which is 5 in this case. Finally, we return the out list. Next, I'm going to run the test cases. Okay, compilation error, let me fix that. Oh. Okay, let me rerun the test case. Okay, all the tests passed. Next, I'm going to submit this program. Cool, this program is accepted. Next, I'm going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. So first, we initialize the out list to the empty list, and for this input matrix, the max number of rows is 3 and the column is 3 and the total number of elements is 9. First, we initialize the boundary for the unvisited part of the matrix. So first, the entire matrix is unvisited, so the top left cells row and column indexes is assigned to start row and start column, and the row and the column index of the bottom right cell will be initialized to end row and end column. Okay, so 0 comma 0 and 2 comma 2. Okay, then we initialize the row and column index of the next element to be processed. So first element is the top left cell, so the row is 0 and the column is 0. First, the traversal is done horizontally from left to right direction, so that's why horizontal is set to true and the left to right direction is also set to true and the top to bottom flag is set to false. Okay, so now next we are entering the for loop. There we check whether the count is greater than 0. In this case it is 9, so there are 9 elements that needs to be traversed. Okay, so first thing we do is we add the element present in the row and column index matrix and add it to the out list. Okay, so the right now the row and column is pointing to the top left cell 0 comma 0. So when we enter the loop it is 0 comma 0, so we read that cell and add it to the out list. Okay, then we increment the column index depending on the conditions, like whether the current traversal is horizontal. In this case this is the horizontal traversal, and then we check whether we are moving left to right. So here it is true, we are moving left to right. Then we check whether the current column index, which is 0, is less than the end column index, which is 2. Okay, so that means this condition is true, we simply increment the column index and move on to the next iteration. So now the row and column index point to the cell 0, 1, right. So in the iteration 1, we read that cell and add it to the out list. So basically the purple cells are added to the out list. Okay. The cell in the red color will be read in the next iteration. After we increment the column or row index, I indicate where that next cell is present. Okay. So here after we read the second cell, we decrement the count. So the count becomes 7. So there are 7 remaining cells present in the matrix. Okay. So the next cell will be 0, 2. So that's what this variable indicates. And we are still moving in the left to right direction. So that's why horizontal is true and left to right is true. So this is the last cell in that row. Okay. Next in the iteration 2, we read the cell 0, 2 and add it to the out list and update the count so that the remaining 6 elements needs to be processed. Once we process the entire row, we have to change the direction to top to bottom. Okay. So the current column index is 2. So we are checking whether the current column index is less than the end column index. In this case, it is less than or equal to the end column index. So we move to the else part where we change the direction by setting the horizontal flag to false. Okay. So that's what we are seeing here. And then we indicate the direction whether it is a top to bottom or bottom to top. So here when we do the traversal left to right, the next vertical traversal will always be top to bottom. So that's why we indicate top to bottom equal to true. Okay. So and then we have to exclude this row from the future traversal. So we increment the start row so that we adjust the boundary of unvisited portion of the matrix. Okay. Then we increment the row index so that this is the next element that needs to be processed. So we have to adjust the row index also. That's why we are incrementing the row. So we see here the row is 1. When we enter this iteration, row was 0, but now it is incremented to 1. But the column index remains same because we are going to traverse in the same column but in a different row. Okay. So then we come to the iteration 3, and in the iteration 3 we read the value 6 and add it to the out list and decrement the count. It becomes 5. Now we check whether the direction is horizontal. In this case it is vertical. So we come here and then we are doing it top to bottom, and then we check whether the current row is less than end row. So the current row is 1 and the end row is 2. So this condition is true. So we simply increment the row index so that the next cell will be read is at 2, 2. Okay. So that we see the 2, 2. Okay. And the iteration 4, we read that cell, the value present in that cell, and add it to the out list and decrement the count. So the remaining 4 elements are there. So once we reach the, so in this case, after reading that, we check whether the row is less than end row. But in this case, the row is equal to the end row. So now we have to change the direction. So what we are doing, we are setting the horizontal flag to true so that the next traversal is done horizontally. But it has to be right to left. So that's why the left to right flag is set to false to indicate the traversal is done right to left horizontally. Okay, and then the end column is decremented so that the unvisited portion of the matrix boundary is updated, and the column index is decremented so that the next element to be read is pointed by the row and column correctly, so that the next element to be read present in the next column, so that the next element present in that row will be read. Then in the iteration 5, we read that element present in the row 2 and column 1 and add it to the out list, and then we check whether the column index is greater than the starting column. So in this case the column index is 1 and the starting column index is 0. So this condition is true. We simply decrement the column index, and in the next iteration we will read this value. Okay, and also we update the count variable so that we still need to process only these 3 cells. The next iteration, the cell present at 2, 0 is read. Once that is added to the check whether the column is greater than starting column, but in this case the column is equal to the starting column. So that means we have to change the direction from horizontal to vertical and bottom to top. Okay, so for that what we are doing, we are setting the horizontal flag to false and top to bottom flags to false, and we update. Next we exclude the last row that we traverse, so that's why we decrement the end row, and then we update the row index also so that it points to the correct element to be read in the next iteration. Okay, so in the iteration 7 the 4 is read and added to the out list. So the row is greater than or equal to start row, but in this case it is equal to the start row, so we have to change the direction of the traversal. So now it has to change it to horizontal, so that's why we set the flag horizontal to true and the left to right flag to true. Okay, and we have to exclude the column just we finished processing this column, so that's why we increment the start column index and then the column plus plus, so that it points to the next element to be read. So in the iteration 8 we read that element present in that index 1, 1 and add it to the out list, and then when we check whether the column is less than end column, but in this case they are equal, so we simply increment the row index, so the row index becomes 2, and we update the count so that now no more element needs to be traversed, all the elements are traversed, so the count becomes 0. So when we come, so the for loop ends, at the end we come out and return the out list. So this is the spiral order output of this matrix, so that is the expected output. Next I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. Okay, so this matrix is a 3 by 3 matrix and it has totally 9 cells. So in order to generate the spiral output of this matrix, we have to traverse all the 9 cells. So the for loop performs 9 iterations. So the matrix is m by n size. Totally there will be m times n cells. So the for loop needs to perform m times n iterations. So the time complexity is order of m times n. Space complexity is order of 1 because we are not allocating any additional space for the intermediate processing. We are not allocating any additional space in terms of the input size, so the space complexity is order of 1. Thanks for watching this video. Have a great day.